Oh, people are here. Hang on. Oh, webcam. What do you... Okay. So, pretty much, my... I kind of... Stream has... what the hell is my webcam doing? So, basically, I've had one heck of a day. I've been basically busy constantly, except in the afternoon where I had a nap, and that was like my break for the day. And so, yeah, I've had no time to like get my stream set up, which is not useful. Why is this working like this? Okay, right. Wow. Okay, well... Okay, we're switching to my crappy laptop webcam. This is not the usual polish, but... right, okay. IBS. Okay. Bear with. I also don't really have an idea for what's a good thing to do today. Let's zoom in the terminal a bit. Ooh, is my audio really loud as well? If it is, just shout. Because I also haven't had a chance to, set up a proper microphone that's like right next to me. Anyway, what I thought we could do is not do anything to Sapling's code base, because what I need to figure out right now really is we need to sort out how nodes are stored in Sapling, because the current system is very far from ideal, and it only works for JSON. So we kind of need to do some, a design decision needs to be made for how to do this. And it's a pretty gnarly problem, all things considering. You've got loads of things that you have to do, loads of things that it has to do. And the current system just fails really badly at stuff like being nice to edit. It really isn't. The rest of the code of Sapling is horrible because of representation of stuff. And it also can't be parsed easily, and it just throws away all of the formatting data of the document, which is all very well. I think that's kind of acceptable to have the option to do that, but the issue is that if you were to open some document in Sapling, let's say, do I have my thing.json? I say I were to just mash all this into one line and save it, and then I were to open the same thing in Sapling, cargo run this, then it will read the internal structure of the JSON and build the tree in its kind of pretty format, right? And then I would write to disk quit, and then if I open thing.json again, it's different. Okay, and for JSON that's okay because this is the same data, but for some programming languages, like this is very far from ideal. Can you imagine if I opened some source code like this and it reformatted everything? That's not really acceptable. Some editors do it, a lot of things format on save, but that's different. This will kill all the formatting. And even rustfmt, which is one of the most aggressive formatters I know of, doesn't kill all of the formatting. So what I thought we would do is try and parse JSON in such a way that we can preserve the, we parse JSON from a grammar, so not from handwritten parsing code, from a specification. Oh, sorry, visitor pattern. Martin says, thinking that maybe a visitor pattern would solve the code mess. I mean, like, definitely, I am very open for, like, trying every different way. Like, the first way you try is never going to be the best. Or at least, like, there's no reason to assume that the first thing that gets tried is going to be the best. Like, the only way to know with a reasonable degree of confidence that you've got something that's decent, or that's, like, good, is to have tried a lot of other things, right? So definitely, yeah, the more attempts, the merrier. And also, you have kind of free run of the code base right now, because I'm... Like, I have other projects that I'm working on right now, degree-related ones, so merge conflicts won't really be an issue. But anyway, yeah, we should probably cd out of Sapling. Oh, I have way too many things. Let's make a new directory and call it Sapling parse test. Cargo init. No, this is a binary. Okay, right. Let's vim source main. Okay, Rust analyzer is new. Okay, yeah, sure. I'm fine with having the latest version of Rust analyzer. So basically, what we need to do is, I'm not going the same route as we had last time, which is, if you remember from a few streams ago, if you knew, basically, like, Sapling parses JSON by parsing JSON. Like, it uses Rust's JSON parser from Serde and parses the JSON into a data structure, then reads the data structure that has been parsed into its own format. Like, you know, that's not an ideal solution, because a lot of that's not scalable. Like, we couldn't do that for Rust code without, like, pulling in the entire compiler as a dependency. This is clearly unscalable, and also it destroys a heck of a lot of the formatting data, well, all of it, right? And it destroys other information about the source tree as well, which is, yes, some things that should be representable aren't big through that method. So basically, we need some kind of way of specifying a grammar. And for anyone who hasn't done like a formal computer science course, basically the way you would represent this kind of thing is we would have JSON, and this is like going to be there's Syncray, which also supports fan. Well, so here's the thing, right? Because there's a whole debate about, like, because a lot of people ask me, like, oh yeah, why didn't you use tree sitter? And the thing is, like, yes, I do want to use tree sitter. Specifically, I want to use the grammars from tree sitter, because like, other people have done the work, right? Tree sitter has tons and tons of very good grammars for a lot of languages, and it would just be insanity to try and redo all of that work. So definitely, I want to import, at the very least, import grammars from tree sitter. But the thing is that the way tree sitter works and the way Sapling works are very different. And that's not a criticism of tree sitter. It's just the two programs are built with very different purposes. Tree sitter is very specifically for a text editor, right? It's built for Atom and has plugins for other things, but it's designed specifically for adding syntax highlighting to text, right? That's the important thing. So the kind of control flow of tree sitter is the user edits some text. The text is like the ground truth representation of whatever you're editing, and then tree sitter reparses the syntax tree as, like, slices, like pointers into the text. So it's like, hey, this region of your text is this bit of the syntax tree, and then it rebuilds the syntax tree out of the text. And there's no reparsing step, right? Like, you can't unparse a tree sitter AST, right? Because what does that even mean? That doesn't mean anything, because the tree sitter syntax tree is, like, it's embedded in the text, if you like. So the tree sitter model is you have text and then you embed a syntax tree in it. Whereas Sapling's model is you have a syntax tree, and programmers aren't used to dealing with syntax trees, so in order to actually display it to the user and write it to a file, like, you have to convert it into text. So you store and manipulate a syntax tree and then parse it back into text when necessary. In fact, Sapling doesn't even do this. It doesn't even do the conversion to text stage. When it displays it to the screen, it tokenizes it and then doesn't even just convert to text. It just stops there. And that's where the syntax highlighting happens. Because what will basically happen is it will say, as it's unparsing, it will go, oh yeah, well, there's an open bracket here. And the open bracket is some punctuation, so it's going to be this white color. And then the next up, we have, like, 1 line down and 4 indents in, we have true. And true is a constant, so it should be red, or whatever the specified color is, then a comma, which is white, and so on. Like, Sapling isn't even converting to text here. It's just figuring out where to put stuff on the screen so it looks like text. So I don't think the whole using spans thing is useful. Like, it might be, but I think just storing a syntax tree with associated white space data is the approach that's required for Sapling. At least that's my gut feeling, because the whole point of Sapling is that you edit syntax trees. Like, internally, all Sapling is doing is editing syntax trees, perhaps with associated data about, like, the text they came from. And I hope, like, I can kind of imagine that, like, this will have cool side effects that just taking spans out of text won't. Right? Because imagine that we opened some JSON that actually did look like this, and we haven't just reformatted it. What we can do, I mean, converting span to white space data. Oh, okay, right. I'm sorry. I get. Oh no. Okay, so yeah, I get now. So you were saying, like, yeah, use the syn crate and then parse out of the syn crate instead of pulling in the compiler as a dependency. I think that is what you're saying. But still, it's not, like, that's clearly not a solution. In fact, the person who made Tree Sitter did some talks about Tree Sitter and explained a similar thing, which is that you really don't want to have to pull in the parsers from every language, right? Because JSON and Rust are all very well. They're already Rust implementations. Okay, good. Yeah, exactly. Okay. But I mean, like, yeah, the rant I made was new, I think, anyway. But the way the person who made Tree Sitter explained this as well, which is that this is all very well for these two cases, right? Like, XML is probably, there are parsers for that. Markdown, there's a parser in Rust. All of these are Rust libraries. And I'd rather not pull them in as dependencies, but if I had to, that's okay. But what happens if we get to, say, Go or Python, right? Like, there are parsers for them, but they're written in Go and Python, respectively. Like, how do we do that? Do we pull in a Go library, like, and call it through FFI? Like, how do you do that? And how do you even parse such a complicated data structure between them? Like, the Python parser, do you bundle a Python interpreter? And, like, what about JavaScript, which all of the stuff is written in JavaScript? Do we bundle Node along with Sapling, right? Like, this is getting insane. So what Tree Sitter, the people behind Tree Sitter decided, and what I think, what I see no reason to reject their decision, is to build all of the grammars in a custom language. And so, oh, hold on, OBS is being stupid again. It hasn't updated any of my stuff. Oh, we do like displaying how many users I have. How many viewers. Hold on, what? It was this one, right? This is why using my PC, which I'm not because I didn't have time to set it up, is so much easier because I'm just doing a screencast. It doesn't matter about like which windows are where. Anyway, so the grammar that I was going to test implementing right now is something like, let's just make a comment. It's pretty much right. You've got a load of rules, okay, and on the left-hand side of a rule is this is a kind of what are they called? They're called variables or non-terminals, right? In fact, let's just make this even easier, right? Let's imagine that we have a language which is all of the correct pairings of brackets, right? So like this is fine because the brackets are evenly paired, but this is not because we've got an uneven pairing of brackets somewhere. Yeah, one thing I was thinking about when playing with XML impl is maybe it's possible to write derives for structs to implement tree traits and generate structs from the grammar. Yes, that is fine, but I think I don't think there's any... Oh, my audio is really loud again. I mean, I guess everyone's turned it down at this point, but I really shouldn't be going over 0 decibels. Yes, yeah, like you're so on the same lines. Yeah, that's exactly the pros are you get static checking, you get speed of code, but it's hard coded. My real kind of issue with that is that once we're specifying everything from a grammar, I don't actually see very much difference between all of the different tree types, because I think from the user's perspective, I'd ideally like Sapling to feel very language independent, right? Like you wouldn't want to have an editor where you can open Rust code and it works really, really well for Rust code, and it technically is cross-platform, but in order to now open a C file, then you have to like download a new piece of code, right? Because it's a built-in binary that we're dynamically linking for every language. So it'll be like, hey, Sapling can't understand this language that you've just opened, and so we're going to have to pull in another dependency. We're going to dynamically link it, load it, and then start running it. Whereas in reality, like languages are just syntax as far as Sapling is concerned. I don't think there's much reason to have much more than that, and syntax should just be specified by a grammar, I think. So my ideal scenario would be not to have any trait impls around the AST trait at all, like to just take it out. We have a concrete AST implementation, and it tracks all of the details. Also, there's a little bit of an obscurity, which is that can I go back? No, that was Sapling. So if I look at the code, like a lot of the code is very janky, right? Because it's all very well, okay, so how do I explain this? So basically, my strings have edge cases. Yes, so strings kind of do, because, yeah, I agree that strings are edge cases. But the thing is that, like, the issue really is that strings are, like, different languages have very different string implementations. But fundamentally, they're all some form of escaped strings, right? I think any stringy node in the tree, whether that be a variable name, string literal, like you name it, comment even, I think they can all be represented. Yes. So I don't think we should go with classic grammars. Yeah, you're quite right. Like classic grammars represent chars, like strings as lists of chars. I mean, technically, they don't even do that. They represent them as cons lists of chars, which is even worse, because you've now got, like, it's not even like you've got a string node with tons and tons of chars as its children, right? You've got a string node with another string node as its child with like left branches, right? So you kind of like doubled the number of nodes that you actually need. But what I was thinking is that actually all string classes, like all ways of putting strings in any language, are fundamentally like you could just. Yes, yeah, or yeah, absolutely. At a minimum, my language for defining grammars must do that. I think it should also do a lot of other things. Like it needs to give default key bindings for all of the things as well, like node types. And what else? It needs to have. Okay, we don't care about tree validation because that's built into a grammar. That's like what a grammar is. But the thing is, so here's my thinking, that basically like strings in languages of like any just raw string, if you like, stuff that can't be decomposed further. Like the string, the idea of a custom string data type really is that it's kind of like you should, for purity, if you're just like editing a tree and everything should be a tree, you should keep going and break strings down further. But for actual like sanity, like of the user, you need to stop at strings, right? String is the lowest level you'll go. But the mapping between strings and like actual like text on disk is simply escaping rules. Like it's some kind of transformation. Like you might add stuff on either end, like quotes, right? And then there'll be a list of escaping rules, like in a lot of languages, \n, well, this is vim thing, or just vim without a file name. So we've got something like \n goes to, in fact, how do I even explain this? Like \n goes to the new line, literal, and then we obviously got \/ goes to / is literal. But I like all of these escaping rules are literally just rules, like they are just that, and so and they have a strict inverse, right? Because implicitly everything else, like dot in the kind of regex notation, goes to dot, right? Or how should I do this? Maybe x. All right, so like any arbitrary thing that's not covered yet is just passed through untouched. So you've got so any string, I think, is covered by one. You need what do you insert on either side, and we can kind of like visualize this as like this is kind of like how format bang works in Rust, right? So you would be like, so strings in say JSON have quotes around them, so it would be like this. Missing thing. So you got some kind of final transformation that's like, oh yeah, well how do you like say that, make sure that this is a string literal and not anything other piece of code, and that's because you need quotes on either side. So it's kind of like this, I guess, for JSON. And then 2, we've got like what escaping rules are there. And this is just a mapping between chars. So this is char to char. But it's a function that maps chars into chars. And then 3, lastly, is like what is valid. Because in some cases, if we're going to expand, like one thing I'm trying to minimize in Sapling is the number of edge cases we have to deal with. Because edge cases are bad for the user because they have to learn them separately. So ideally, everything that's kind of stringy in any form should have the same interface, and therefore you need a what is valid. And in JSON strings, this is anything, right? Like escaping a structure. Oh, sorry. Yes. It's a mapping between yeah, it's a mapping. Yes, you're quite right. And importantly, this is, yeah, it's true. I think someone's using the bath next door, which is why there's just like random bath sounds happening. And then what is valid? This is simply a regex. And I think these three rules are enough to cover everything, or at least everything that I've thought about. Because, for example, like Rust variable names are like one, what do you insert either side? That's nothing. Like you simply pass the name across. That there's no, like, you don't put Rust names in quotes or whatever. What escaping rules are there? None. So this is just identity. Identity function. And then three, like, what's valid? Well, I'm probably going to butcher this, but the Rust identifiers, that's A to Z, like, you've got to start with some character that's either an underscore or it's a character. No, sorry, or it's some alpha character, not numbers, right? Because you can't start a Rust variable name with a number; it doesn't work. Yeah, I didn't need to demonstrate this. And then it's A to Z, like any lowercase letter, any uppercase letter, any digit, and underscore forever. And this is a regex that will satisfy Rust variable names. Oh, typical. Like, literally. So Rust apparently does have escaping rules to support additions. But, like, for the sake of argument, you could, for the sake of being easy on the user, like, also they won't be very complicated, is what I'm trying to say. That might be right, but it's fine because we support escaping rules. And the important thing is that escaping rules, this has to be invertible. Because when the user reads some stuff, yes, yeah, that's right. Like little details like that are probably not worth implementing in Sapling. Although, it's just effort on us, right? Like, the users, if it's very light escaping, like, I don't know, sometimes underscores aren't allowed or something, I don't know, or underscores get escaped, I don't know, whatever it is. If it's very light, then the only time, then it won't crop up very often, so it won't actually be a headache for the user. So yeah, this would be my ideal way of representing strings. And this could just be specified as part of the grammar. You have a regex, a big list of what escaping happens. We need a macro, I guess, something to do Unicode characters properly. So because, for example, like 0x, what's it useful? Like 1b is escape key. Oh Jesus! Like, why? Don't they know that doing that? Actually, wait. So the fact that escaping rules are strings to strings, does that actually matter? So long as it's invertible, I think it's fine. Because, like, by the very nature of how escaping works, it has to be a two-way process, and it has to be a what's the word? It has to be a perfectly invertible process. You can't. Escaping has got to be an invertible process because you can't lose data by escaping and then de-escaping something. That's just not an option, right? That doesn't make sense. So I think this is fine, and like I could keep going. What else could we have? So for example, we could have Rust string literals. Well, the first part, they get put in quotes. Then, what's the escaping list? Oh, of course, because of keywords. Okay, so in fact, the what's allowed is even more complicated, right? Because it's this, but not. How do I do that? How do I do this in regexes? Like I want this, but not any keyword. We can figure that out later. And Rust string list rules. Well, the only thing that's not allowed in them. So I guess we have to make sure that what is valid is it's a regex over de-escaped stuff. De-escaped string. Like, does this make sense as well? Because I could be missing something quite obvious, or there's some weird edge case. Because like obviously, in fact, yeah, because Rust doesn't even have any rules about like this is what is it? It's dot star, the regex that matches everything. There aren't any rules about what de-escape stuff is, and then we've got all of the rules like backtick quote goes to quote, \x. What even is this? Yeah, we need some stuff like Unicode 16 as, I don't know, some kind of literal goes to Unicode 16. I don't know how to say this, but like is it messy though? So like I'm not sure what should happen if someone editing Sapling makes an identifier into a keyword. Because if you think about how the grammar of how the language would work, right? Identifiers and keywords are different types in the syntax tree, and I'm trying to avoid a situation where the user edits something and like edits the string property inside a node, and then when they exit string mode, however that will work, the type of the thing suddenly changes, right? Because it could suddenly invalidate the entire tree. It's much better to say, oh yeah, you can't name a variable if, and if you try and do that, you obviously the grammar won't. If the grammar tokenizes before parsing, which nearly all grammars do, tree sitter doesn't because it needs to be fast. But there's another reason not to use tree sitter is that we don't actually care about the use case that tree sitter has, which is that it needs to parse little changes very quickly. So yeah, is that even valid Rust? Right. Defo not rambling. Right, let's see. I'm intrigued now. Let r hash match. What? My mind is actually blown now. What? Please, what? How is this allowed? Is hash valid inside string names? Is that what's going on? But okay, so is this okay? Oh, this is really scary. Why? What? So can I put anything after r hash? Is this a valid thing? So is this okay? What? This is completely weird. Like, what is even going on here? I'm mega confused. So, if I'm right in thinking that r hash any variable name, so in this situation, can I get yeah, no, like I can see the reasoning why you would want to be able to escape identifiers. It's just that, like, what even? So can I say, like, let v equal this plus what? Ah. Oh, okay. No, I think I understand because yeah, it's literally just that anything starting with r hash must be an identifier, and not a thing. So we can say, like, r hash let. Oh, yes. Yeah, that makes sense. Okay, so basically, like, that is... what was my thing? It was definitely not rambling, right? Yeah. Ah, so how would you do that? That's jank. Well, that makes... Because what you'd want to do is to just remove... You, like, only add the r hash when necessary. So our actual transformation is r hash bang if is a keyword, which is unfortunately not very grammar friendly, because, like, if we keep going like this, then we've got a Turing complete grammar language, and I'm really trying to avoid having a Turing complete language for specifying, like, any kind of configuration language should not be Turing complete, in my opinion, because okay, so it should be Turing complete and already be a language. Like, we should use Python, and that's Turing complete, or we should use a custom format and not make it Turing complete. Because my issue is that it seems like no one does a good job of writing a Turing complete programming language as a configuration for another program, right? Like, VimScript is horrible, Emacs Lisp is horrible. What else? All of the zillions of different config files I had to deal with, whilst making my PC work, right? Like, I dealt with so many different file formats. Like, how does that even work? So like, basically, I really don't want to have a Turing complete language that I've just created for a program. Like, Python is perfectly fine. It's bloated, but, like, heck, so is VimScript. Like, at least Python exists and has library support. But I'm not sure even if that's the right way of doing configuration. But definitely for grammars, it makes sense to have some kind of grammar language. And then, ideally, I'd like every language in Sapling to simply be a grammar. Like, you shouldn't have to recompile the editor or do any dynamic linking, in my opinion. Like, we might have to, and that would be unfortunate. Like, okay, let's, like, take a step back, which is that it might be something we need to do in order to get it to work fast enough. But until we actually need speed, I don't think it's worth... Like, I think this is just better. You have a text editor, and then it has some kind of specification of a grammar, and if you need to have another language, then you just download the thing, and... yes. Well, so my... okay, yeah, so it is insanely difficult to avoid adding things to a specification language and avoid Turing completeness. But the thing is, having a Turing complete startup script is very useful for a variety of reasons. But, for example, like, the easiest thing, like, when I was configuring all of the programs that I needed on my PC, because I installed Arch Linux because I hate myself, and it's actually great now, but it took me forever to get it working. And it took me forever to get it working mostly because dealing with so many different config formats is annoying, right? And the easiest ones were ones where the config was a shell script, because I know how shell works, or a Python script, and I already know how those languages work. And all I needed to do was to go, oh yeah, well, what are the what are the commands I have to use? Or in Python, what are the functions I have to use in order to get things to work? I didn't have to use a horrible thing. And also, other people have put effort, people who know what they're doing with programming languages, have put effort into making those languages nice. And that makes a difference. But there are, so on the point of, avoiding Turing completeness, there are some very good cases, examples to aspire to, in my opinion. So one of them is SQL is not Turing complete, and it's very, very intentionally not Turing complete. The person who invented SQL, I think it was a guy called Cod, great name, Cod with 2 Ds, by the way. He very explicitly said in the paper where he explained the earliest form of what now became SQL, was that the whole point of this language is to load stuff out of databases, and there's no reason to do stuff Turing complete. What I want is to be able to guarantee that something written in this language will terminate and is guaranteed to terminate. You don't want to give a database query that never finishes, or get stuck in an infinite loop. And so it needs to terminate always, and it needs to be fast and easy to optimize. That were the two things. And Turing complete languages just fail both of them. How insane, how huge is LLVM as a project? And literally all they're doing is 90% of LLVM is optimizing a Turing complete language. A very simple one even. It's LLVM's representation of machine code. Can you imagine trying to do that to, say, Python? It'd just be insane. So there is precedent for making very useful not Turing complete languages. And I think the language specification should be written in a grammar where 90% of the language specification is not Turing complete. Because, can you imagine a grammar specification that gets stuck in an infinite loop? Right, that would just be the worst. You'd open a file, and it's provably impossible to detect when things are never going to exit. So it's impossible for Sapling to step in and go, hey, look here, you're never going to terminate parsing this file. Just, give me what you've done already. I also don't think context-free grammars are the way forwards, but, yeah. I don't know, it's a kind of gnarly problem, really, the whole, how do you specify grammars? But the thing is, what I quite like is to have a centralized repository somewhere of all of the grammars for Sapling. And when you open a file, Sapling is it looks up, it keeps a local copy of whatever the repository of grammars is somewhere. It could be a GitHub repository even. And then whenever you open I don't know, a Rust file, it goes, oh, hey, I've got this big list of what file extensions use which grammar, what grammars, and then it's oh yeah, this is a Rust program. Do I have Rust already? No. Then I run a fetch request to say, oh, give me the latest Rust grammar, and then download it as text, right? It's just a grammar specification. Then parse, perhaps, JIT compile-ish the grammar into something more readable and faster. But, I still think we could just interpret grammars. I think that would be fast enough, because people aren't going to be opening ridiculously big things. And anyway, it's not for tree sitter, the grammar gets reparsed every time the user presses a key. And text editors have to be snappish, in order to feel responsive, right? 1/10 of a second is the generally accepted upper bound of how quickly a human would expect their inputs to take effect. And a tenth of a second is even like noticeably sluggish, right? I would say like you've got to do it. Ideally, something has to change within maybe like a millisecond. I think is 10 milliseconds, a hundredth of a second. That would be like my ideal, in order for an editor to feel like snappy. But also like Sapling is not. Yes, that's my fear too. Is that you'll need some weird rule, and then you'll have to do it. Like maybe linking stuff in is the right way, and then for the I don't know, maybe the 90% of languages which adhere to the basic thing, you have like a compiler that compiles grammars into the linkable binary format, and then that's just like how you do it. I don't know, but you've got to be really careful that one, your grammar is correct, right? Like that's the first thing, and the less Turing complete your thing is, the easier it is to reason with. In fact, something resembling a context-free grammar would be ideal for this. You've got to guarantee that the that's okay. So yeah, purposefully declarative, and yeah, because I feel like this is the issue really at heart with functional programming. Really, is that it's very declarative, and actually that's very pretty in most trivial cases, but if you actually try and do it in practice, you're like, yes, but I need to like change this variable on the second run through a loop or something, and I just don't want to use recursion all the time. I don't know. It's a bit of a gnarly problem. What I might PEG. I've encountered PEGs before. What is PEG? Parsing expression grammar. Here we go. Yeah, snap. I've found the thing. Yes, I've encountered these before in the context of the fact that Rust's grammar is not context-free, but it is expressible as a peg. In fact, I think this is how. How do I start the story? So basically, like, I did a Christmas project 2 Christmases ago. One Christmas ago. Like, not last one, but the one before that. Where it was for our degree for the compilers module, and we had to do some editing. Like, we had to do some tasks to a compiler for a very simple language. It was written in Camel. The compiler, and I think the parser in that, so it had a handwritten parser for the language that we were editing, the compiler. So it had a. Right, I'm confusing myself. So the compiler that we were working on had a handwritten parser, and I think it was written like this. I think it was using PEGs. Except it was written monadically. It was really bizarre. It was like just some weird monad stuff that I think did exactly the same thing as a PEG. Oh yeah, here we go. So it says any parsing grammar can be converted directly into a recursive descent parser. So here's my thinking, right? Which is that ideally you'd like some kind of level of abstraction where everything is expressible in a simple format. And since most languages have to be parsable, right? Like, yeah. So, okay. So here's the thing. Let's say, like, I'm trying to write some kind of format to parse expressions, right, in some language. And the thing is that languages that we're editing are not just like created by a user to stimulus. Like, they're not made by evil people. They're made by people who are fundamentally doing the same thing as us, right? Like, the compiler for every language has to parse the language at some point. So programming languages, grammars, are inherently parsable. So I think it's reasonable to assume that we might be able to make some kind of format that does express everything, or nearly everything, right? Although it is a bit of a deal breaker if part of the language breaks. But also, the example that's set before us is that tree sitter already does this. Like, tree sitter has a very simple grammar structure. It is, I think, almost always context free, or it might be. I don't know. It turns into LR parsing or something. So there exists precedent for what I am thinking of doing. Okay, so there exists programs already that parse nearly every language, is what I'm trying to say. And therefore, if we are trying to like this is already something that is already done, because every compiler for every language has to parse the language at some point, and tree sitters manage nearly everything. It doesn't do string de-escaping, which is one thing that Sapling will have to do. But I really don't think there are too many nasty edge cases, because the only, like, that has to be done as well for any language to be run, right? Like, for any programming language to work, you have to be able to de-escape the strings within it. That's just like part of parsing. So I mean, I hate to, like, this is very famous last words, but I don't think there will be very many edge cases. And if there are, then they will be edge cases that crop up a lot, like the whole, like, Unicode, Unicode escaping, for example. You just need a rule where you're like, hey, we take this series of hexadecimal digits and we interpret them as binary, and that's that character code. And then we need a set of rules for things that we're guaranteed to have to de-escape. We're going to have to escape, right? Because you can't, in a lot of languages, you can't just de-escape things back. Yeah, I guess that could be a little bit gnarly. Like, you'd have to specify which ranges the languages allow, but do things. I think C doesn't support Unicode characters. Like, anything out of ASCII is sometimes not supported by C compilers, so we kind of can't have the option of. This is annoying though, right? Because imagine you edited some string, right, that had, I don't know, even some, what is it? 1-3 is character return, isn't it? So let's say we edited this string, or even something even easier, like what's A? A is 65. Heck, what's 65 in? 65 is 2-1, right, in hex. So what I'm basically thinking about, right, is, let's say Sapling encounters this. What can we think of that's like, hey, yeah, like, so we've got A and then A but written as a Unicode escape, right? What I don't really want is for Sapling to, like, you open this, you start editing the string, Sapling goes, oh yeah, well, okay, well, what's x21? Well, that's capital A, so it opens it and then goes, like, it goes, yeah, like this, and it goes, oh yeah, these are two A's, and then you're in string mode, and then you do some edits, and then you go back out of string mode, it re-escapes the string, goes, oh well, capital A doesn't need to be escaped, and now you've ended up with you've done nothing, but you've ended up with different text. Like in the case of A, it's obviously fine, but like what happens if you inserted like an emoji or something? Also, Unicode is a pain. Like, what's valid Unicode? Oh god. Why? Like, oh yeah, don't breathe water, guys. Water is not breathable. Okay, I mean, I think where were we at before I tried to suffocate myself? Yeah, we were like, what should you do with like escaping strings? Because so I think that, yeah, I would say that it can't be excluded. The problem of like.
Ready when you are.
Awesome. Yeah, so right, like you got the problem of like what happens if some language gives you a like some horrible janky edge case that more chat has happened. Supporting both. Oh, so like being able to edit escaped versions and de-escaped versions. I mean, I think that should be fine, right? Because you could have like S and then Shift S for edit de-escaped version, and then obviously like you can represent any, you could convert any set of escaping rules into a regex, and then when the user's editing, you can just scan their string with a regex and highlight which bits of it fail the regex. So when they're typing, you can be like, hey, if you, let's say you got this string and then you started editing it as in unescaped mode, then and you like inserted a quote, right? Like, this is not a valid string anymore. If you were doing it in escaped mode, you would put it in, and then as soon as you exit, it would escape it for you. So I guess it might be like unsafe, and then it would reparse and go, hey, this is an error. Because that's the other thing. The other reason why. This is another thing that I don't want. Like, I'm loath to have all of the possible languages be separate structs, like completely separate structures, or even worse, like not worse per se, but like I would prefer all nodes in the syntax tree to be one data type. Like all nodes in any possible language to be one data type, and this is because we can add stuff like errors, like custom error nodes. So like if you open some invalid stuff, you've got to kind of support that. But you also want to parse as much of the text as possible. You can't just say, oh, well, I'm sorry you gave me some invalid code. You ideally want to parse most of the tree, and then, like, I don't know, the offending line is just an error. And if you don't even edit the error, then, like, who cares? It's an error. We don't mind. It will just, like, parse it back to disk, and hopefully the compiler will break. But the thing is, I think that these obscure, like, having a language that's obscure enough to break any sensible parser, like, in our parsing specification, right? Like, whatever we choose, like, whether we choose pegs or just a simple CFG, or whatever tree sitter's got. Tree sitter works fine. So I think it's kind of like saying, oh, you might end up with a case where static typing doesn't work, which is, like, perfectly true. There are some things that are really, really hard to express in static typing. Static type checking is not Turing complete, and it's guaranteed to finish. So it's kind of like analogous to parsing stuff according to a specification. And, like, in fact, it might even be isomorphic or like completely equivalent. I would rather not. I would rather try. This is another thing that TreeSitter does, right? So we can import, if we can import TreeSitter's grammars, then we kind of get this for free. Like, we have to implement it, but someone else has done the hard work of figuring out what's an error and what isn't. So yeah, like obviously the user, there will be cases where the user will have to fall back on Vim to do an edit. But I think, let's say you had, oh, where are we at? Let's quit out of this and then make an error somewhere in thing.json, right? So let's say we put this. That's nice. Even Vim has figured out that this is an error, right? So this is invalid, but this is the only bit that's invalid. Like this broken string here is the bit that's invalid. Everything else is fine. And if we save this, and I'm pretty sure if we trying to open this now, it will just reject. Yeah, here we go. So thread main expected comma or backtick. Okay. Which the thing is, this is not a very useful solution. Like what I would prefer is to do exactly what Vim does, right? And that's to open the file anyway, and then highlight the offending bit of text in red. And then let's say I navigated down the tree, like I would start selecting everything. Or like I would be selecting the root node. Because also cursors and selections are kind of the same thing in Sapling, right? Because a cursor is not just selecting one node, it's selecting a node and the subtree underneath it. You think, like, are you sure that the usefulness of parsing invalid code is low? I think it is high. I think it's very useful to be able to parse invalid code. At any rate, it's something that we ought to support early, because building it back in, like, what's the word, retrofitting it, is going to be hard, I think. But at any rate, I don't have the time to, like, do stuff. Because the thing is, you also know, if I was editing this, right, like, I know what this, I know what node type this invalid string is supposed to be. Like, I know it's supposed to be some kind of JSON, right? Like string, true, false, null, you name it. And like, so I could get the user to edit this as text, as like the stringy stuff, right? Like, and then the user could escape this and everything's fine. And then they could save it. And then just this node would reparse and say, oh yeah, it's a string. And it would go, oh yeah, well, so it's a JSON thing, and more specifically, it's a string. That's what my thinking is, as far as that is concerned. And I think it's time for me to go as well. But yeah, I mean, yeah. Is it? Yeah, I thought that was a decent stream, to be honest, because like I didn't do much coding, but that's fine. I'm like way too tired. Yeah, I don't know. I just feel like this is something that what I don't want to happen. Like, okay, so yes, you store valid code on disk 99.99% of the time, but there's also a problem, which is like, how often is the grammar of Sapling going to be perfect? Because I think that's very unlikely, given how difficult it is to like make grammars in the first place. So the issue is that that I see is that there's some mistake in the grammar in Sapling, and when the user opens a file that is legit, yeah, I mean, yeah, I have the same thing, because format on save, like, only formats on save if the code I'm editing is valid, syntactically anyway. So I also have the same thing, that I'm like, yeah, if my code doesn't reformat when I save it, then something must be wrong. So I go fix it. But yeah, I mean, it might be something that's worth experimenting with. Hopefully I'll have more time to work on Sapling next year, when I'm not doing the third-year project. Because the issue really is that my third-year project is in Rust, because I wanted it to be. And like, I spend quite a lot of time doing it. And the issue is that by the end of a day of like, I don't know, 5 or 6 hours coding that, I'm not really in a particularly good mood for like going and like working on more Rust code, if you see what I mean. Like, I just want a break from, ideally just a break from screen time. Well, so Tree Sitter already handles mistakes, so like, yes, it's a gnarly problem how to like handle invalid code, and basically it comes down to heuristics, right? You can do a lot better in Rust. In fact, we can see like Rust Analyzer does a really good job with this, right? Because if we go to no, I don't need to do this. Source main, right? If we make some syntax error, Rust Analyzer, which is one of the things about like oh, you mean mistakes in the grammar? Yeah, I don't know. I by far my ideal scenario is to have Sapling always be able to edit a file, and just handle incorrect stuff as like localize the issue. Because like the thing is, I think localizing a syntax error is relatively straightforward in most cases, because a lot of languages allow you. Python is annoying because it's interpreted, but let's stick with compiled languages to start. Like if I were to add a syntax error here, Rust Analyzer is very quick to pick that up. Like, and it knows exactly where the thing is. Like, say I say let if equals 3, or let if in 3. Okay, it knows precisely that the syntax error is in here, because you like in Rust code you have these like open brackets, right? And you have this chunk of code, and you know as soon as you see opening and closing curly braces that the code inside that has to be a block, right? Like, you can treat all of the code inside that as one syntax tree node, and the same with semicolons. So whenever you hit a semicolon, you're just give up on the previous thing that I've been parsing and then move on to the next one. So what I would like Sapling to do is, when it opens this, highlight all of this in red, because it's like, this is clearly not an expression. Like, what the heck are you playing at? Like, don't give me this. But also, most of the rest of the file is fine. So you should be able to edit this. And then just in like every enum. Yeah, I mean, yes, messing up braces is the worst. And I think Rust Analyzer will handle this very badly. Yeah, exactly. So Rust Analyzer does exactly what I would expect, which is that it matches up these braces, and rather than saying this brace is in the wrong place, it rejects all of the rest of the code. But the thing is, I don't think this is a common issue, right? Because so also, if we do this, then the root node of the file fails to parse. So we're just left with like the root node is an error. Would it be? No, actually, the root node, everything up to line 37 parses correctly, and then this thing is an invalid, like, it's an error of type whatever can go in the top level, right? Which is like imports, functions, trait, definitions, impls, you name it, right? Like, that's and this whole chunk will be an error. But the thing is, you could edit the root node as text and then get rid of this error, and it would reparse the entire file and everything would be fine, except this, which is wrong. But it would still localize the error. The way Tree Sitter handles this is that it has a ton of heuristics built in for like, it will kind of, as it's parsing, it will parse from top to bottom, and then if it sees something it can't resolve, and like even languages that don't have LR compatible grammars, whenever it reaches something that it can't decide what to do, it just branches and starts parsing twice, and all of the parsing operations, like consuming closed brackets or something, have associated costs, and then by the time it gets to the end of the file, like it chooses, like it has at some point it's like, oh yeah, only have three existing branches at any one time, and at some point it gets to like a fourth, and it's like, oh well, we'll just reject the one with the highest cost because it's clearly wrong, and then at that point it knows where the errors are. So I think tree sitter would reject the semicolon. It would reject the brace here instead of everything. But yeah, I mean, I think we get error handling basically for free if we piggyback tree sitter, and I think that's just the same thing to do with a new project. Like someone else has already done a lot of the hard work with like making grammars, so it seems completely insane to redo all that work for not much point. Like there's no gain doing that, as far as I'm concerned. Yeah, I mean, like all of this is very, very gnarly. Like I feel like the only way to actually shed light, on this situation is to simply try and implement it, right, and see what happens. But yeah, I think that's going to be it for today. I need to hoof off. But it has been fun. I enjoyed it. Yeah, exactly. Yeah, copy as much as possible. I'd rather not use tree sitter completely, because tree sitter's grammars are written in JavaScript, which is just like one of the worst things. Like, why? But anyway, so what I'd quite like is to have a thing that compiles tree sitter's grammars into whatever grammar we have, and then we can keep our own grammars, but keep whenever like anyone bug fixes tree sitter's grammars, we can also pull them across, right, and use them for Sapling. But I think like where Sapling is currently, that's quite a long way down the line that we'll need to do something like that. Yeah, hopefully next academic year will be the year for Sapling. Yeah, I know. I mean, so yeah, JS is definitely cry as far as I'm concerned. But for tree sitter, it kind of it does actually make some sense, because tree sitter is built into Atom, which itself is running Electron. So Atom is entirely scripted in JavaScript or TypeScript, and so it actually makes some sense for the people using Atom to, like, the only thing you could really rely on is that they know JavaScript. But also, it just becomes really ludicrous, because if literally the grammars are, they're not even like saying stuff in JavaScript. It's not like, oh, well, we did it in JavaScript so that someone could import like something from the compiler and build and generate TypeScript grammar, generate tree sitter grammars on the fly, right, with JavaScript. It's literally like everyone has just built the grammar as a big JavaScript expression that gets evaluated, and then the like C++ backend to Node that they've implemented builds a grammar, like an in-memory grammar of like literally the same. So it's kind of just like parsing by running JavaScript, and then as it's like JavaScript is walking down the syntax tree of the JavaScript code, as Node is like running this JavaScript, is actually parsing the syntax tree and like running down the tree of the expression, and then it like builds it up. And I'm like, why? Just, yeah. Anyway, rant aside, I don't want to Like, yeah, I mean, it was it was a choice, and it seems to be a decent one because TreeSitter works. I, yes, that was my exact opinion, and also I just like Node is huge, like as a dependency as well. So in order to natively run TreeSitter grammars, because like the process of TreeSitter, right, is that you have this JavaScript file which is literally a grammar, and in order to get the grammar into some format that TreeSitter can use, like JavaScript is too slow for the speed that TreeSitter needs to work. So the JavaScript stuff is executed, and then there's a Node.js library that's written in C++, I think, C++, that reads this grammar, converts it into a parser, generates C code of the parser, and then the parser is compiled as a C dynamic library and then linked at runtime. So like doing that from inside an editor means that you've got to pull in Node as a dependency, like custom dependency, because you can't just use Node because you've got your own C++ thing. And you've got to import GCC as well, or a C compiler, in order to do the compilation. You've got to have all of the FFI bindings, which, to be fair, they've written Rust bindings for, so that's okay. But, like, I really don't want to pull in all those dependencies. Like, Sapling already has quite a lot of dependencies. Like, I've got cargo tree. Yeah. Okay, this is not huge, but, you know, it's still kind of more dependencies than... No, I think it's fine, but I don't want it to get much bigger than this. Is what I'm getting at. Anyway, for like the third time, I think it's time to wrap up. So, yeah, it was a fun stream. I enjoyed it. I've been ringing for like what 4 or 5 hours today online, and it's like, my brain is so tired. And then by today I mean from midnight. So I was ringing at midnight. And we fired out the first quarter bill, so we were ringing from midnight to like 1:30, and and then like I had to get up at 10:30, so like the amount of time I had to sleep is not very big. Actually, I realised that's like what 9.5 hours, 9.25, 9.25, 8 3/4 hours. I can't do maths; it's too late. Someone else can figure it out. But anyway, yeah. The upshot is I'm quite tired, but it's fine because I enjoyed stream and I hope you did too. So I'm going to wrap it up here. So bye. Where is the thing?